Hello, we're back. I hope you had a
Hello,
good
hello.
lunch. So, Simo, what's coming up now?
Yeah, so now we are we already got from the great CSC talk that we had before the lunch, we had a quick glimpse of what it actually looks like to run stuff on the HPC clusters. We saw some magical terminal stuff happening there and that sort of stuff. And here now we are going to be actually like now hopefully you had a good lunch and you're full of energy to type a lot of commands. So now we are actually like going to go through a various things on how to run stuff in the cluster, and we will like start working on the clusters itself. So we had a glimpse of what it is to work in a cluster. Now we're going to be working on a cluster, and these are easily transferable, this information, to the other sites. Like, so there might be some differences between sites, but in the notes, if you ask questions, if you encounter any problems, just ask there. And all of these lessons that we are coming up to, we will talk about bit about like what's what, like theory, but we'll mainly focus on demos that we have prepared, and then we'll have plenty of time for exercises where you can do the same demos as well, and do the same like things that we do, plus some extra exercises if you feel like it. And yeah, first we'll look at the clusters. What are they? So was that a good
Yeah,
intro, Richard? On
sounds good. Yeah, so we've already gone over clusters a bit, but remind us, so what's the important part and what's going to make these exercises difficult?
well, hopefully not difficult, but it might be a bit different than what you have been used to. So in the previous talk, we already had a bit of a mention regarding what is a cluster. And what is a cluster? Well, it's a collection of computers, basically, like computers that have special jobs, and you can use them uh, through this queue system. And how it's organized, like typically a cluster, is that it has some login node, a place where you can log into the computer, and then it has some data storage. In case of Triton, we have two file systems. We have this home for like small scripts and maybe your logging information, and then we have this scratch storage, which is the main work storage. And here is where you usually spend most of your, like, you put all of your code here, you put your data here, and here's what stores your results and stores your code. But when you want to run stuff, you actually run the code through the queue system in these computers called nodes often. Like node just means a computer. So we have CPU nodes that have only CPUs and memory, of course. And then we have GPU nodes that have CPUs and memory, but they also have GPU cards that you can reserve to run your code if it can run on GPUs.
Yes. Okay, that's a good
And
introduction. So once we're actually, or was there something else? Or
yeah,
once we're
Reddit.
actually using it, what do we do? I mean, I
Well,
start with my own computer, and I guess I've developed something there. Um,
yeah.
what?
Yeah, how it usually goes,
Yeah.
like when you start working in a cluster, it has a workflow, something akin to this uh, this setup here. So often you just, like when you start a new project, you have this initial setup phase where you usually like have to set up everything to work, and then you run stuff in the cluster. So the initial setup is basically you go to the cluster. Usually you immediately go to your work directory because that's the main place where you want to store your stuff. And when I say you go to the, like, we are going to be using terminals to like change directories. You change the directory to your work directory, and then usually you get your code into the cluster. You get the data that your code uses into the cluster somewhere in the work directory. and then you install the software needed by your code.
Yeah.
And this is like the initial setup that you usually do.
Yeah.
And
So there's a fair amount.
Yeah.
Like, how long does this initial setup usually take?
Well, it depends on a project. If it's a code that you have already created and you have, let's say, a version control, your code in version control, you can easily transfer the code over there. If you have your data already in order, you can usually quite easily transfer it there. So that shouldn't take long. Sometimes the software installation, if the cluster has all the software you need, no problem. Then you just use that. Otherwise, you might need to do some installations or ask help doing the installations for the code, and that might take some time. But usually this is like when we talk about a project, it's like a few days, maybe like a week, if it doesn't go smoothly, kind of a thing.
Yeah.
But usually like you start it up like from minutes to few days maybe. But the actual meet,
So basically, be prepared. It's not instant to just get running, but reserve some time and to like do this.
It's like if you think about your computer is your home, your laptop is your home, and you go abroad on a hotel, you stay in a hotel. You want to like first put your stuff into the right places. So maybe you go to like a cottage, you have rented a cottage. You want to put your stuff in the right places, and then you can start actually like seeing what are the sites in the city, or start hiking now that you have your base set up.
Yeah. Okay. So in this little loop where you run something, you see if it works, you edit code, and you run again, how does that work? What are these options for?
So most of the time, usually when you do stuff in the cluster, you are in this sort of a loop where you run something in the queue system, you usually submit it through the queue system, and then you check the results. Okay, well, were they good? And then you just keep going until you get the results that you want. And here the edit your code basically carries a lot of weight. So because this is and checking the results, it's like very like self-evident, but how do you actually do it? Like there's multiple ways you can do it. Like it involves like what way do you want to use the cluster? And here's some examples. Hope the text is not too small, but examples that you could use. So in this course, we will be mainly editing the code in a terminal because that's available for everybody. So what you can do is like you can in a command line terminal you can open the files and you can edit the code directly, and then you can do modifications to the files, and then you can submit them to the queue. Some people want to edit the codes in their own computers and then use something like Git to like the version control system to push the stuff into like, let's say GitHub or version Aalto file, these kind of version control systems, and then get it into the cluster and use that to transfer like changes to your code. Some people like easier option is usually to get the file system available in your laptop. So you can basically mount. So mounting means that you basically make it available in your computer, the Triton file system or the cluster file system. So you can do the edits with the editor, whatever edit you want in your laptop, and it will transfer all of the changes into the cluster. Or you can use an editor that remotely connects to the cluster. So this might be like VS Code remote shell, or it might be like you use the Jupyter in the on demand or something like that, or you might use the virtual desktop through the on demand. But there's multiple ways you can do it, and it's really important to pick one that suits your like work style, because in the grand scheme of things of the workflow, you are going to be spending most of your time over here in the loop. So try to pick a style that makes it much like easiest to do the edits in the cluster itself, so that you don't have to like constantly transfer stuff back and forth. Like it's easier to like do the things in the cluster itself. But okay, enough about the
Okay,
workflows. We should
yeah.
move forwards and look at an actual example.
Yeah, so what's our example? What are we going to demonstrate?
Yeah, go a bit back. So we need to get our code to the cluster.
Well, first, can you talk a little bit about what the example will be and what our
Yeah,
overall plan for the day
yeah.
will be?
So I think the example is an example about the calculating these n-grams, and it's stored in this examples repository that we have. And maybe Richard, you can explain what are n-grams and what does the code do?
Yeah, so what this example is, okay, there's a cat that's like trying to sit on keyboards and stuff like that, so I can't type that well.
Mhm.
Okay, so in this example, we have books from Project Gutenberg, which are open source book, or no, it's it's digital copies of public domain books from long ago. And with the books, we'll do some text analysis. So the sample code we have divides the books into words and then computes all the sequences of words. So for example, there might be the um, the house. So how many occurrences do you have of the house, or every pair of two words, or three words, or one words, or whatever? And this gives us sort of an interesting insight to what the books are. And well, people like doing text processing these days because it's close to what language models are doing. We're not anywhere near close to that, but you can sort of see the starting point there. So we have this code, it's called the n-grams example, and it will be like, we'll keep doing it through the whole rest of the day and keep developing it slowly over time. Okay,
Yeah, so maybe we should uh,
yeah,
start
uh,
demoing how can you get the code in the
yeah,
cluster. So first things first,
okay.
I have logged into the cluster over here.
Oh, and I guess we should say, first, are
Mhm.
we going to do some demos and then we'll give time for people to do the exercises? Is that,
Yeah, so
I believe that's correct. Okay,
you can focus on the what we'll be typing here, uh,
yeah.
and then you can do it in peace afterwards.
Yeah, so I'd recommend focus on watching what we're doing and then later focus on typing and doing it yourself because trying to follow and type along at the same time will be hard.
Yeah,
Also, for what we're doing, we'll demonstrate something that works on the Triton cluster, but you'll have to adapt it for other clusters because because every cluster is different. It may have different storage locations, different
yeah,
options you need. So ask in the notes and whatever. And if you can't do it on whatever cluster you're on, that's okay. Just if it goes completely off the rails, then just stop, switch to watching mode, and just watch, and then take the time later to figure out what went wrong. Remember, all the materials in the videos will be available for later. Okay, so copying the code. Um,
yeah.
So the
So
code is currently in a version control repository in, I guess it's in GitHub. So that, which means anyone can clone it with the git command. And hopefully every cluster has git installed by
yeah,
default without any extra stuff.
yeah, and now we are. I have a terminal open here. I have taken an SSH connection to Triton beforehand, so
Mhm.
I won't be showing that. I all of the commands I'm going to be typing are going to be shown here at the bottom, so you can see the history of the commands. And that's I've set it up so I don't want to break it by doing another connection
Yeah.
to Triton. But first things first, what we usually want to do in a cluster is go to the working
Okay.
directory.
So,
Uh,
and this is the first place that clusters may be different. So on Triton,
mm,
we have this variable called work directory, which will lead to our scratch directory, which we'll actually talk about shortly. Um,
And
Other clusters, every cluster probably has a variable called home, which is a home directory, which works there. Actually, should we just use home because that works for everyone? Or
like if you don't have a working directory, or if you don't know what the cluster working directory is, you can use the home directory. But I would recommend using the work directory because it's good to get the muscle memory in there to go to your cluster's work directory always. Because usually you want to do everything there anyway, so it's good to do that. But if you don't know what the work directory is, you can use the home directory, of course. And you can use the command pwd to print working directory, so which directory you are currently in or which directory the terminal is in. So in the terminal, you are basically always in some directory, and all the commands that you're going to be running are running relative to that directory. So if like when I did the pwd, it shows now that I'm here, and the cd is change directory, so you can change directory to a new directory.
yes,
So
okay. So we've changed there, and next up is a command, a git clone command, which should work for everyone. Git clone https github.com Aalto SciComp HPC examples. Yes. And if we do this, now if Simo runs the ls command, we see there's a bunch of directories here, which are from previous work, but now we see HPC examples, and we can change that directory with the command cd. So right now we're not going through the details of what all these shell commands means. The first time we use it, we'll try to say what it is, but this is not a shell course. We've listed some shell courses and materials as part of the preparation for the course, and you can go read there or later.
yeah,
But okay.
ls is a list, so list files in the directory, so you can use that to check what files are available.
Okay, and now we've got the code here. So now we need to get the data.
Yeah.
So how do we do that?
So for that, let's try, for this case, we'll try using on demand to do that.
Okay. So we're going to demonstrate a somewhat realistic way of doing things. So that we're pretending the data is not available online. So first you download the data to your computer, and then we'll upload it via the on-demand service to the cluster. So basically using a web interface.
We'll
And
post
there's
the
many
links.
different ways to there's many different ways to copy data. We're trying to give a couple options that will work for most people without problems.
So I will copy it by first download it into my own computer by going to the link. We'll post a link to the notes for the data, and I'll store it into my computer's temp folder for now. And now it has been downloaded there. It's quite a small file, so it's it's already downloaded. So
nice and fast.
Next step is to log into the on-demand server that we are using.
Okay.
You can also use this to get the terminal if you don't, like with the Triton shell access, if you don't want to take an SSH connection, or if you have problems with the SSH connection. But let me make this a bit. So yeah, so on the top bar, there's files over here. And over here, I can go to work directory.
Okay, got it, yeah. And now what we see here corresponds to what is in what we saw in the terminal.
Yes.
So two views of the same thing.
Let's create a new directory for that so that we don't immediately lose track of where the files will be stored. So let's create a new directory.
So Gutenberg-fiction is what the examples say. Okay?
Yeah. So now I get a new folder over here, and if I go over here, I can now see that there's nothing over here in the file system. I can upload a file.
Yes.
Let's
Okay,
browse
browse
files.
files.
Yes, the Gutenberg.
Gutenberg fiction.
And let's upload it.
Load. Okay. Takes a little bit longer. And now should we go back to the terminal and see if we can see the
Yes,
new data
let's do that.
visible there?
So
Okay.
I'm currently in the HPC examples folder. So if I want to go one folder back, I can type cd ... So I will be then in the work directory. And if we go to the Gutenberg fiction folder, I can see that, okay, now the file is there.
Yeah.
So I'll navigate back into the HPC examples because that's where we want to be. And you can
Yes.
usually use a tab
And
to autocomplete, like the tab character. You can use that to autocomplete. Like if you have
yeah.
started writing something, if you see that I'm typing something and something appears, it's just that I'm so used to pressing the autocomplete, I forget that I use it. So
Okay.
don't worry about it.
So there, we've transferred the data. Should we do an initial test to see if the code runs?
Yes. Yeah.
Okay.
So which
So
folder is it?
we can stay in this folder. So if you
Okay.
do Python and then space, then ngrams. Yes, Python 30 ngrams. It is count.py. And actually, you can first run it with the -- help option. So
Yeah.
this is something that each program has to do itself. But when a program has a -- help option, it usually tells you a bit about what is like how you use the program.
Mm.
And it can really be helpful when figuring out some new command line stuff.
Yeah. Yeah, most commands, like if you run, let's say, cd -help, it has a help manual that shows
Yeah.
what it does. And like most of the
Yeah.
commands in Linux, they, at least system commands, they have this --help included. So
Yes.
let's check the
So
engrams.
So I happen to know that we need the one input argument, which is the input text file, but it can also be an input zip file. So we will do Python 3 ngrams count.py. And now we're going to refer to the data that's in a different directory. So we start with dat ... which means go up to the parent directory, and then Gutenberg fiction as the directory.
Then I
And
press
then
tab
the
and
zip
it,
file name.
yeah,
Yes.
yeah. So
Okay.
now should I run it?
Yeah, let's push enter and see what happens. So this should analyze 100 books in there and print out all the word frequencies. No, sorry. Cats is getting hungry and starting to look for cables to eat, which is
Yeah, it's a
always a
good
fun
time
time of day.
to have the exercise in a second so that you can feed the
Yeah.
cat. Yeah.
Okay, well, it finished. So what do we see? So by default, it prints out just word frequencies. So word 1 grams. And then, uh, and it also prints out just letters. So let's modify how it runs. Can we run it again, but with a -- words option?
Yeah. I press the up arrow on my keyboard to get the previous command. So this is very useful for if you want to do modifications or something. You can press up arrow to get the previous command, and you can use the left and right arrows to go like scroll in the command itself. So we can write something in the middle of the
Yeah,
like place.
in the middle. Yeah,
Yeah.
we're modifying. Yes, okay.
Yeah.
So I hope it's -- words that doesn't. Well, yeah,
At
okay.
least seem to work.
Yeah. And I guess while we're waiting now, so what will come next? This will be an example for you. So it looked pretty simple when we did it, but of course, lots of things can go wrong for you. So, for
Mm.
example, how you copy data to your cluster. If you don't have on-demand, you need to copy it either by the command line, or you can use this wget command in order to um, um, download
Download
it
file from the internet,
directly
yeah.
by the command line.
So it's like web get
Yeah.
something from the internet, downloads a file.
You need to figure out where to store the data, whether it's in your home directory or some other Scratch or work directory that's available on your cluster. You need to be connected. So different things can go wrong here.
But let's not focus on
Yeah,
what can go wrong. Let's focus on what you are able to do. So what if you
yeah,
like throughout this exercise, we have basically completed the initial setup because this code doesn't require any installation or specific installation. We have basically completed the initial setup of our program, and now we can start working in the cluster. So
yeah,
in the exercise, like basically we now this is the thing you usually need to do when you do any initial setup. You get
yeah,
usually a code repository into the cluster, and then you move your data into the cluster. And once you
yeah,
get that done, vast majority of like stuff ends there, and then you can start running.
yeah. And this is definitely an artificial example compared to usual work because it's designed to have no dependencies and work only by Python, and the data file is nice and small. But anyway, we're about to go now. I've put the exercise here in the notes so you can see, try to repeat what we just did, that kind of stuff. Um, if you have problems, ask questions down here. And don't worry, we expect there to be plenty of problems. We will give some time. You can also report, I am, why is this not updating? Oh, I'm writing in the wrong place. Too many windows open. Done. And then comment on the problems you have down below, and we'll try to help you. If you're in Finland, you can join the Zoom we have and get interactive help. Is now when we wish people good luck.
Yeah,
Is now when
well,
we apologize for needing
no,
luck to get it to work.
but I think it's like this is the kind of problem that like once it's annoying first,
Mm,
and it's annoying because of like historical reasons and lots of stuff, and
yeah,
but it's also like once you get it sorted, then
yeah,
like it quickly becomes a rote thing that you do often.
yeah, yeah. And there's already one person saying it's too easy.
Uh,
In that case, if you look at the different links from the schedule, there's a lot of more advanced stuff to try that lets you really see a little bit deeper into things here. So I'd say do that, scroll down to the exercises and
yeah.
um,
and
try that.
and and in the boat, just add an O character there,
Yeah,
because then there's less risk of people adding like counting at the same time and doing this kind of like if you ever played the
yeah,
game where you need to count up to a certain number, you know how hard it is. So it's
yeah,
easier to just add an O there. So so yes, so let's set up the projects and add any
uh,
problems that you have into the chat. We'll try to answer them. So
yeah. How
have
long
fun.
should we give? Um,
Uh, I'd
20
say
minutes, 15 minutes?
15 minutes. Let's say 15.
Okay,
Like,
yeah. Okay, great. Good luck and see you soon. Bye.
bye.
Okay, hello, welcome back. And from looking at the notes here, it seems things went pretty well. Y'all actually did really well. Um, you make me proud. So, yeah, like really
And
what
this
we do
is,
now is probably one of the hardest things we've done or we'll do the whole course. Just the idea of having all these abstract folders on some other remote system, needing to keep track of what is where and where all the data goes is quite a hard thing.
yeah, usually like if it's like the cluster is bit of like it's like your computer, but it's like again it's like different. So stuff is in different places, and
Yeah.
especially if you're used to using graphical interfaces and stuff, the terminal can become seem daunting to do. But basically, it's the same kind of thing that you would do in your normal operating system, like opening a file browser or something and going to a folder and opening a file. But all of that is done via the command line, because then you can program basically and like you can tell the computer exactly what you want to do. And that's why the command line is so popular in the HPC clusters, because you need to be able to tell the computer what sort of like operations, like file system operations it needs to do, like go to this folder, move this file around, and that sort of stuff. And this is often the most annoying part when it comes to using the clusters, like the transferring of files and managing this kind of like, especially if you have like copy of your code in your computer and then you want it to be in sync with the code in the cluster. So yeah, like the getting accustomed to the like, okay, there's another place that has this only that I cannot see, but I can only ask it, like it's like you can only use the terminal interface to or often you only use the terminal interface to interact with it. It can
Mhm.
be a bit abstract, but once you get a hold of it, it becomes easier. Uh, so Richard,
Yeah.
if you want to share my screen for a second,
Yes.
I could show a few of the like a refresher of a few of the commands that we did.
Yeah.
So
Okay.
when it comes to like this kind of like terminal files or terminal, it looks like we just have like a blank screen over here, but it's always in a folder. Like we are always in some folder, and the folders are organized in Linux. They are organized with these slashes, and everything starts at a root. And then usually you have, let's say in our case, we have the work directory is like /scratch work and whatever. And this is the so-called like absolute path to the folder. So if we have the HPC examples over here, we can see like here's the folder. And if I run pwd, I can see that this is my current directory, and like I'm currently here. And of course, and you can also have like relative paths. So you can have paths relative to this folder. So you can, let's say, have the dash dot dot, meaning folder below, like above me, like one folder above, and then like Gutenberg fiction. So it's basically like you have this, like every folder is separated by these forward slashes, and then like you have this hierarchy of folders inside of it. So and getting accustomed to navigating this kind of like maze of folders can be a bit daunting at first, but it's always good to remember that pwd shows what folder you are in. You can use ls to list whatever files you have in that current directory. And if you want, you can always use cd to go back into your home directory. So you can, where you start. If you run just cd without any commands, and you can give it the whole path if you want to go to like back into some directory, you can like get cd a path, and then you can go back into directory. And this is what like it's first daunting, but once you get accustomed and you know that now your files are in this kind of like folder structure, it becomes easier over time.
Yeah. Did you talk about what the ... means to go up one
Yeah.
directory?
Yes.
Yeah.
And
Okay.
you can chain it as well. Like you can have ... go one level up, and then you can go 2 levels up, and so forth, and like you can go up and up and up until you reach the
Yeah.
end. But
Yeah.
yeah.
So one other thing I saw in the notes several times was about the zip files. So this is sort of interesting. So we've written the program where it can analyze books directly from the zip file without you needing to uncompress it yourself. So this was an interesting choice of ours. It meant that it didn't take up as many files. Like um, it's more efficient in some ways. Um, yeah, but it's just an interesting design choice. Also, there was a good question about where the data was um, saved. And for that, well, I don't know. I can't find it in here. Yeah, here it is. Where's it saved? So in this case, right now, the program is just printing it out from the printing it to the terminal and not saving it anywhere. There's an option to save the output somewhere, which actually we will start using later on. Were there any other very important things we should talk about?
Uh, I will quickly mention that like all of the commands in in Linux, like they have this syntax, like this form that you can like follow. That first command is like the actual name of the command that will be executed. So let's say the Python 3 will be the command that will be executed, and whatever you give after that are so-called like arguments. Like you can give arguments to the command. So let's say if I have the count.py, I can give it as an argument. So like I will run the command Python 3, and this is called an argument, and it's usually called a positional argument if it doesn't have anything to highlight it. It's just like it's the next one in the line, and then you can give more arguments. Like you can give like for example, we gave the name of the input file, the zip file that we want to process. That's another argument. And you can also have these dash arguments, or sometimes with single dash arguments that are like special toggles or options that like toggle different like features of the program. So for example, the words was this kind of thing. And all of the commands usually like are written in such syntax. Like of course there's always exceptions to the rule, but all of the operating system commands, they follow this syntax. It's like back from the Unix days, like it's very old syntax. So once you figure this out, you know that, and use that's as help, for example, it will make everything easier in the terminal.
uh, there's several questions of similar things up above. So when you're running it from the command line, well, really anytime you run things, but um, things are really picky about how you give the paths and what you use. So for example, if someone gives the path to a directory, then and it expects a file, that doesn't work. In this case, I think the problem is
I think it's the direct.
this person. You need to give a .zip as part of the file name on here. So in Unix, well, yeah, really anywhere, but Unix, what you give is what it uses. So it doesn't automatically add or remove file names from anywhere. I propose we go to a break now. We can keep answering some questions and we'll come back and move on. And if things are still not working quite right, please let us know you had problems down here and we will be aware of that for next time. But during the break, even if this hasn't worked yet, consider how cool it is what we just did. So since we're typing things on a terminal, it has several effects. One, you can copy what you typed and put it in another notepad and remember what you did. And that's much easier than remembering where you did a bunch of clicking. Second, since we're typing it here, we can make another program called the shell script that will run these programs automatically for us. So instead of having to sit there and click buttons to run something 100 times or 1,000 times, we can run 100 things at once with just a little bit of work. And this is our first step in that direction. And that is without a doubt cool and what makes clusters useful. So with that said, I guess we have a 10-minute break and we'll come back at 8 minutes past the hour.
Sounds good.
Okay, sounds good. See you then. Bye.
Bye.